Good day! In this video, we are going to do the 2023 NCEA Level 2 Apply Algebraic Method in Solving Problem question number 3D. This is an excellent question and we're going to do it very slowly. So without further ado, let's try to solve this problem. Okay, so the question sounds like this. Okay, so I run out of space, so I'm going to bring it up all the way. Okay, so the diagram below shows the cross-section of a canal and the narrow boat floating in the canal. So the blue thing is the canal, okay, and the boat, the narrow boat is the bottom of the narrow boat is the blue little stuff there. Okay, the surface of the water between point A and point B, okay, measures 2.5 meters across. The canal is 3 meters deep. The cross-section can be modeled by a quadratic graph ACB. So we're going to do ACB in this graph, okay? Because it is 2.5 meters, we're going to put at 0 here. So halfway between 0 is 1.25 and minus 1.25. And the depth is 0.3 because it's 3 meters depth deep, okay? Sorry. The cross-section of narrow boat of the canal can be modeled by rectangle of a width 2.2. This is 2.2, okay? And we're going to use the midpoint, which is 1.1 later on in the calculation, okay? The narrow boat, this is more important. The narrow boat must maintain a constant depth below the water of 1 meter for the boat to float. So will the narrow boat be able to float? And we need to solve that equation. So first, you look at this quadratic equation because they tell you about the quadratic equation, 1.25 and minus 1.25. We need to find the equation of that graph. So to get the equation of this quadratic, we're going to do y equals to a x minus 1.25 x plus 1.25, because this is a quadratic. 1.25 on the right minus 1.25 on the left. So our objective now is to find the scale factor a. To find the scale factor a, we need to substitute the value. So we're going to let this point here, or 0.3 here, okay? So when x equals to 0, y equal to 3 meters, we're going to substitute this value into that equation. So y, which is going to be 3, equals to a. Remember our objective to find the scale factor a, okay? So x is 0, so 0 minus 1.25 equals to minus 1.25. 0 plus 1.25 is 1.25, okay? So now the next thing you need to do, because this is minus 3, because it's below the surface, going to be minus 3, sorry, okay? We're going to multiply these two numbers. So when you multiply 1.25 and minus 1.25, it's going to be, so on the left-hand side it still remain, it's going to be minus 1.5625a. You multiply these two numbers, you get minus 1.5625a. To get your a, you just need to divide, when you divide by negative 1.5625 on both sides, so a equals to minus 3 divided by minus 1.5625, and your a has been found to be 1.92. So the equation of the quadratic is going to be y equals to 1.92. Substitute back into this equation, x minus 1.25, x plus 1.25. So far so good? Great. So now because the point here in the middle of the boat is going to be 1.1 meter, we need to substitute when x equals to 1.1, because that's the middle of the boat, okay? We're going to substitute them. So we're going to get the depth is going to be y equals to 1.92. X is now 1.1, 1.1 minus 1.25, and then 1.1 plus 1.25. Now I need to use some calculation, and I did it before. It's going to be this number here. It's going to be minus 0.6768, okay, meter. So that depth is going to be minus 6768. You need to answer the question, will the narrow boat be able to float in the canal? The answer is the edge of the canal is only 0.76768 meters below the water surface, okay, below the water surface. So the boat will not be able to float. If you answer that, okay, so you won't be able to float. So that is an excellent in this paper, and I'll see you in the next one. Cheers everyone, and have a great day.